Nez, and I am with the Freshwater Mussel Project, and today I'm going to be talking about freshwater mussels and climate change. Can you hear me?
Yeah, you can see the screen now.
Sorry, you can keep talking if you want. Did I do it?
So why don't you
It's not.
keep talking?
Okay, here it is. Okay, can you guys see my screen now?
Yes.
Hello?
Yes.
Okay.
Yes.
All right, so I'm just going to start. The freshwater mussel outline today I'm going to be talking about. I'm going to start with the background on mussels and then the downfactors of mussel habitat, species in CTUIR waters, life cycle and fish relationships, Walla Walla propagation lab, implementing river vision, and how climate change affects mussel community. So in the DNR mission statement, just to protect, restore, and enhance the first foods, water, salmon, deer, and huckleberry for perpetual cultural, economic, and sovereign benefit of the CTUIR. So the goal of the research is to provide information on the status, distribution, and controls of freshwater mussels. The overall objective is to design a recovery plan for mussels in the Umatilla River and other mid-Columbia River watersheds where mussels may be declining or extinct. So starting off, freshwater mussels are relatively stationary. Once they are in a certain part of the river, they don't really move if they have suitable habitat and water quality. Freshwater mussels, they spend most of their entire life partially or fully buried in mud, sand, or gravel in permanent water. Most species of mussels are found in streams. Some species can be found in ponds or lakes. Mussels stay in place by their foot. They can hunker down in the substrate. It holds them.
Donna, we lost your sound. Can you hear us, Donna?
Winter resting periods, kind of like a tree's rings. How much wording?
Keep talking.
Okay, just tell me like when you can hear me in there. They have rings like trees that tell how old they are. They're filter feeders. Freshwaters feed by taking water through an in-current siphon, which passes over the mucus-covered gills where small food items are collected and then transferred to the mouth. Unplattable items and waste particles are flushed out through an ex-current siphon. By filtering out suspended particles, including impurities, mussels improve water quality, improving quality of streams and lakes. And Colleen, can you hear me? Can anybody hear me?
Yes, we can hear you.
Okay. So next, freshwater mussels, they are able to filter 10 gallons of water per day. They also clean the water in which they live. As filter feeders, they strain large quantities of microscopic materials, such as algae, bacteria, and organic particles out of the water, making them especially sensitive to changes in water quality. And just a fun fact, in a reach of river of 200 yards long, a bed of 100,000 freshwater mussels can filter 30,000 gallons of water. Freshwater mussels have the greatest diversity in North America with 297 recognized species and subspecies that make up the most endangered family of animals in the United States. 69 species have already been listed by the U.S. Fish and Wildlife as endangered or threatened. Freshwater mussels play an important role in the ecosystem. Mussels are an important food source for many animals, including muskrats, minks, otters, fishes, and some birds. Large piles of clean mussels can be called mittens along riverbanks where muskrats are actively foraging. And they play a cultural and traditional resource in historical and today's resources.
Yeah.
Okay. So the downfactors of mussel habitat, habitat degradation, introduction of Asian clams and zebra mussels, pollution, impoundments, loss of host fish, overharvesting, commercial dredging, channel gravel or sand mining, channelization, excess sedimentation, poor land use practices, and water quality changes. So today I'm going to be talking about the 3 species of mussels found here in the Umatilla homelands. Starting off with Gonidea angulata, western rigid mussel. Shells have distinct ridges along the umbo to the posterior valve. It has a smaller absent pseudocardinal tooth. Like I said, they have a strong, Gonidea of all mussels has the strongest anchor for their foot that holds them in the water. They kind of anchor in between boulders to hunker down during high flow events. They prefer runs and riffles in mid to low gradient streams. Their larvae can be found on fish between June and mid-July, and their host fish utilize sculpin. Next, we have Margaritifera falcata, which is the western pearlshell mussel. And their shells can be thick with lateral and pseudocardinal teeth. So they, out of 3 mussels, they have 1 tooth that holds their shells together. And they are found in faster, cooler water and varying gradient streams. They occur in high to mid and low elevations, and their larvae can be found on fish, on gills between April and late May. And they utilize rainbow trout for their host. Next, we have Anodonta floaters species. Their shells are very thin and smooth, and they don't have no teeth. They are very difficult to identify at a species level, and they prefer the low to mid gradient streams and stable backwaters. So they're able to withstand slower moving streams such as Wild Horse Creek. They prefer that habitat up there. Their larvae can be found on fins between early and late June, July, and they're not as host specific as Gonidea or Margaritifera. So theirs ranges from dace, shiners, sculpins, sticklebacks, and some salmonid species. So next we're going to move on to the cultural aspects of freshwater mussels. Mussels, they're an important food source historically. Their shells were used for domestic jewels and jewelry. Native Americans in the Pacific Northwest used mussels for their protein-rich meat. Not all Pacific Northwest tribes used mussels in their diet. Mussels were often collected during salmon fishing or when conditions were favorable. They mostly were eaten during the wintertime when other things were scarce. And use has declined in recent years, but they still remains a reserved treaty right to this day. And we have some examples of a historical collection of shells that we have from the Umatilla town site. And on the right, there's just like an example of a button that an individual whittled out for jewelry. Also, the second one in the middle, those are like little bead clam disc beads. And then just an example of like a mitten that was in the area. So next, we're going to move on to the life cycle, and this was illustrated by Jeremy. So the female freshwater mussel, she carries her eggs inside her shell. They're called gills. The male releases sperm into the water. The sperm enter the female by the incurrent siphon, where the eggs are fertilized internally. And next, fertilization of freshwater mussels takes place within the blood chambers of the female as means of obtaining oxygen. The eggs are soon developed into what is called Glaucidia. And then the Glaucidia will attach to the fins, or if it's Margaritifera or Gonidea, the gills. And then the female then keeps her fertilized eggs in her gills, and then they will become a parasitic stage called Glaucidia. Glaucidia are about as small as a grain of sand at this stage, and they need to come in contact with the specific fish host. So if they don't become in contact with their host, they awfully slough off the fish and die. Successful attachment usually lasts from 1 to 25 weeks, depending on the host, location, and water temperature. After a few weeks, Glaucidia, they undergo cocoon stage, much like a moth, which is called a cyst. And at the last stage, Glaucidia metamorphose into a juvenile freshwater mussel and drop off to the substrate. The time required for Glaucidia metamorphosis varies with temperature and among mussel species. Next, we're going to get into the propagation lab. It's a collaborative effort between the community college and the tribe. And their primary focus is on mussels and lamprey. And research is an early life rearing requirements and identifying barriers to survivorship in the wild. So the propagation goals are to develop and propagate Margaritifera, falcata, Gonidea, and Anodonta. And we want to outplant those propagated adults, and so we can enhance the restoration efforts. And more of that will be in our master mussel sublimation plan, finalized in 2021. Propagated mussels, they determine suitable habitat in the future. So as results, traditional methods for Western mussel species have not been successful. So we are developing a new rearing system using pulse delivery of food and water that has been successful for Anodonta and Margaritifera. The tribe has partnered with USGS in Missouri to develop the technology and use to produce mussels needed for outplanting and restoration work. And for the future, we want to continue testing newly developed propagation methods and long-term rearing to eventually fulfill supplementation plan goals and objectives. So I know Gary he touched on the river vision, so I am just going to, I kind of wanted to tie in the river vision and like what Eric has done in his beginning phases of the river vision. So the goal is to restore floodplain and increase forest foods for tribal member use. So we have the river vision touchstones, and the aquatic biota mussels are an important part of the river ecosystem. They are frequently underrepresented or undervalued as members of a river community, especially during restoration activities. The river vision highlights the role that each member plays in the community. Mussels provide important ecological services for fish and vertebrates in the river, such as nutrient cycling and substrate stabilization. Without them, a river community is lacking certain services and other organisms may be hindered. In the touchstones, mussels are part of the mussel aquatic biota, and they are affected and can influence other touchstones through their relationship to the river environment, including mussels in pre-restoration work and during construction. They can help and protect and preserve existing populations and find areas for mussel restoration by outplanting and monitoring. So for the river vision, we have long-term monitoring sites up in the Umatilla. We also have them in the John Day and the Toucan basins, and they have both shown decreasing and stable populations. Our monitoring in the Umatilla River has shown that previous restoration efforts translocating mussels in mid-2000s was not successful. This was likely due to habitat or host fish issues in the area. And these sites have given us more information about mussel survival and population dynamics, so we can choose sites for future restoration that are likely will be more successful. Okay, so I just kind of wanted to use this older table that was drawn up by Eric years ago. So I wanted to show the floodplain ecology underwater and salmon, and it has the in-stream, riparian, floodplain, and hyperrheic. And Eric, he developed this, he's extending the table, like Gary said, and in this table, it encompasses like all of DNR, and I wanted to focus on the in-stream, riparian, and the floodplain, hyperrheic today. So in this next, it shows that mussels are under the salmon category of extending the table. And so he has like came up with the concept of like a serving order, and like all of these foods are under these different sections, and they're all put out into the longhouse in a serving order. And he has them all in the same order on his table. And so, and mussels are part of that under salmon. So I just like wanted to kind of like give you guys an example of how Eric has organized this, and from the beginning in our longhouse order, and it's been established for centuries, and I think it's a very good way of model that explains and documents this. So lastly, I just want to talk about freshwater mussels and climate change, starting with shell degradation of shells. Historically, we have seen that shells were a lot more thicker historically from the collection that we work with up until Mustelic. Versus today, the shells are like very like weak and thin, brittle, actually. And we concluded that made a guesstimation that it's from the calcium deposits in the river. They're not as strong anymore as they once were. Secondly, weather patterns altering mussel reproduction. We've noticed that during reproduction times, early in the years, that historically they used to like warm up, degrees, and like instead, like we come to find out that instead of like warming up, like the temperature will bounce around. It'll like warm up and it'll like cool off like 2 or 3 degrees, and then like warm up a degree. And so this is altering the mussel reproduction patterns that we have. And so it's kind of tricky because it's we were kind of guessing like when mussels are going to be reproducing. And so next we have loss of mussel beds, and we have an example at the top. You can kind of see a healthy mussel bed, and this was one of our Gonidea beds. This is like one of our #1 strong mussel beds that we've had, and it was located in the middle of Fort John Day. And at the bottom, you can see an example. That's the same mussel bed, and that was taken in 2008. And there's been long documents of mussel beds being totally taken out, and it's like not just here in the Northwest, but like across the United States. And so obviously we have decline in host fish. There's not as many fish in some areas, like such sculpin up in the Umatilla. Rainbow trout are kind of in declining areas, and severe drought is making mussels more susceptible to diseases. So there's been a lot of climate change changes that affect freshwater mussels. So I just want to end my presentation and open it up for some questions. Thank you.
Thank you so much, Donna. That was amazing.